Okay, I'm going to talk to you guys about particulate level diagrams just to help you out a little bit. So we're just going to do these four right here. So let's start with A. So we got calcium hydroxide. So you would want to draw a little Ca circle, okay? And then you would want to have OHs. So you need two OHs. So you got O, I need two O's, and then I need two H's attached to that. So trying to make them attach with my finger, which is sort of difficult on this iPad. Okay, there we go. So we got C is our red one, and then O's are the blue, and then H's. Did it have to look like that? No, it doesn't have to look like that. Just make sure that you've got the correct number of things and that you switch colors or make little stripes or polka dots or color in some and leave some open so that I can tell the difference. Okay? All right. And then we have plus CO2. So CO2, so we're going to make our C a different color. So we got C, and then we need to attach two O's to it. Well, over here in our calcium hydroxide, we made O blue. So we need to make sure that here O is blue as well. So we've got CO2. There we go. Okay, and the next one, so then it produces calcium carbonate. So calcium was red, so I'm going to draw a little red circle. And then carbon was our orange one from the carbon dioxide, so I'm going to need a orange one attached here. And then we have three oxygens, and remember again, oxygen was the blue, so I'm just going to attach three oxygens onto my carbon there. Okay, so that's our calcium carbonate, and then we need to make our water. So hydrogens were green, and our oxygens, again, were blue. So I'm going to do my oxygen first, and then our hydrogens. So we need two hydrogens attached to it, okay? It traditionally looks like Mickey Mouse, but since we haven't talked about shapes yet, I'm not going to make you have the shape correct, okay? So that's the first one. Everything was already balanced, so there's nothing to add here. So, and there were no coefficients to ignore. Okay, the next one is the zinc plus silver nitrate goes to zinc nitrate and silver. So let's ignore, to begin with, let's ignore, these little coefficients in front so that we can just try to draw the actual molecules. So Zn, so we're going to have one Zn circle, okay, and then plus AgNO3, so we're going to have an Ag, and then NO3, so we need an N attached to our Ag, and then that N must have three O's attached to it. Okay, and then that makes zinc nitrate. Well, zinc was our red, so let's bring back out our red. So there's our zinc, and then we've got to draw two of those nitrates now. So our nitrates were the green with the three orange. So I'm just going to put them on opposite sides so I have enough room. It doesn't really matter. I told some of you guys in class that it was okay to just draw the polyatomics as a unit, and that is so okay. If it stays together on both sides, it's a polyatomic on both sides of the equation, I am okay with you just making it one big blob of a color all together. But I'm just trying to be more detailed, I suppose. All right, and then that's plus our silver. You go back over here, remember our silver was the blue one. So we're going to put our silver in there. All right, now you want to go back and you want to take away where we erased our coefficients and we want to see what we have to add. So we need to add if you look here, we've got two silvers, so I need to add another blue circle here. And then we've also got two AgNO3s. So I need to duplicate that as well. So I've got my Ag, and then I want to make my NO3 down below it. Okay, if you can hear my 4-year-old screaming, I apologize, but he's a little bit dramatic. So, all right, there's my NO3. Okay, and sorry that my pictures are such a hot mess, but on this iPad, it's a little bit difficult to draw with your finger, so I'm doing the best I can, and y'all know how artistic I am anyways. All right, the next one, the third one, we're going to ignore again those coefficients in front. Okay, this one's slab full of coefficients. All right, start, we got to make an Al, so that's just one circle. All right, and then we've got to make CuCl2, so make our Cu, and then you need two Cl's attached to it, so you're going to make two Cl's attached to that. And then you've got, that makes AlCl3. Well, remember Al was red. So we've got our red Al and then three Cl's. So we've got Cl, Cl, and Cl. Okay? And then we want to make our copper. Our copper was blue. So we're going to draw our little copper over here by itself. Alright, now you're going to look at the coefficients. So if you remember, I'm going to start at the back of the equation. So we needed 3 of those. So I'm going to draw 3 of my little blue circles. All right, then we've got 2 AlCl3s. So I'm going to duplicate this one once more. So we got 1 of those, and then add my Cl's in there. Okay, and then our CuCl2, so I need 3 of those, so I'm going to need to have my Cu's down here. I'm going to draw them both at one time since I have to switch colors, and then they both need 2 Cl's on them. Man, it's just hard to draw circles on this little sucker. Okay, and then we need 2 Al's, and the Al was our red. So there we go. Okay, so that was the third one. And then the fourth one. All right, the fourth one, last one, we have one coefficient that we need to ignore to begin with, right here. All right, and we've got BaCl2, so we got Ba, be our red circle. Cl2, so we're going to have 2 Cl's, blue circles attached. All right, and then we've got K2SO4, so we got K, and there's 2 of them, so I'm going to do K2, there you go, and this time I'm going to count SO4, that's a polyatomic, and I told you if it appeared on both sides, like it does here, I'm going to count it as a unit, okay, so this time I'm just going to count that SO4 as a unit, okay, because you can do that as well, that's okay. Okay, so there's our SO4. All right, on the other side, we've got barium. All right, and sulfate. Remember, sulfate, we just counted him as one unit and made him orange. All right, and we've got KCl. K were the green. So we got K. And then Cl were blue. All right. Now, you need to make sure that we count our coefficients in here. So we need 2 of this last one I drew. So the KCl. So I need 1 more of my green and 1 more of my blue. And if you look, you should see that you have the same number of colors of each type on both sides. Okay, so that's the whole purpose. Balancing equations. This is what it means. Okay, hope this was helpful.